Hey everyone, welcome to the channel. My name is Nader. In this video, we're going to go over functions in JavaScript. I'm super excited for this video. This is going to be quite a lot of content packed into one video. I spent a bit of extra time going through making a few visuals just to make this concept a little bit easier to understand, because I've seen that this can kind of break the brain a little bit for people seeing it for the first time. So that said, I'm really excited to get into it. Let's take a look at functions together. Alright, so as I mentioned, I've created a whole bunch of drawings for this video just to really hammer in the concepts and to see how things are laid out, because just the code sometimes is a bit hard to see what's happening. So the first thing I want to point out right off the bat is that there are these things in JavaScript called functions, and in fact in every single language there is this thing called a function. And as we go through this, I don't want to belabor the definition too much, but we can think of a function as a way to organize our code into different kind of pieces or blocks, or however you want to think about it, and then give them kind of names for functionality. All right, we're gonna get a lot of practice with this, but I kind of just want to throw out that definition out there. It's just a way to compartmentalize our code into little snippets that we can kind of reuse in different places, and can add more advanced functionality as we learn more about them. In JavaScript in particular, though, there are really two types of, I guess you could say, functions. There is this thing on here over the left, which is like, I guess you could say, the regular function syntax. And then there's this quote-unquote newer arrow function syntax on the right over here. So there's a lot of kind of debates and content online about the differences between these and what they do, and how you should really use one or really use the other. For the purposes of this series and this video, I'm going to mainly go through arrow functions because just they fall better in line with how we've learned about variables up until this point. And in general, I tend to use them most often as they are kind of the lighter, newer version to write syntax for functions. This version on the left is equally valid and sometimes is even a preference thing. However, there is some fundamental differences behind the scenes that are a bit out of scope for this video, which we'll get into in future more advanced videos, that this type of function is more suited to and maybe more useful for, that's not possible with this kind of function, and vice versa as well. So there are kind of very kind of exceptional cases, I guess you could say, where there is a need for this regular function type and the arrow function type as well. But since we're not going to really be dealing with that or handling that kind of in the short term or even the medium term, quite frankly, there's no point really in belaboring this too much. I'm just going to go with kind of the thing that's more in line with how we think about variables so far in this series especially, which is the arrow function syntax, which is also the newer syntax and the lighter syntax when it comes to running JavaScript. So we're going to go with this just so you have a heads up as to how this video is going to proceed. So what is this function thing? You can see over here, if we look at the right, in fact, the syntax for both of these is very similar, so don't get too hung up if you feel like you really want to learn this other type. They pretty much work the exact same way. But for the arrow functions, it's very similar to declaring any other type of variable. All right, over here you can see that I have a const and then the label or the variable name. Right? And then on the right hand side, instead of things like the primitive types that we've seen so far, like the numbers and strings, etc., we have this really funky looking thing, which is some parentheses, and then this arrow, which is actually an equal sign and a greater than sign attached to each other, which I'll show you in the editor when we type this out together, followed by kind of curly brackets, which we've actually seen in curly brackets before. That kind of denotes like a start and end to like a block of code. And that's how functions work as well. Very similar to an if statement or a for loop. The code that we're going to run is going to be in between these blocks of code, these braces of code. The main thing to kind of keep in mind is that it's this area right here that's kind of new, which is what declares this to be a function type instead of something like a string or a number or a boolean, for example. Okay, and it kind of gets its name from this little arrow looking thing over here, as opposed to this other function syntax which doesn't have that arrow. So that's how you can think of it being an arrow function. Okay, and that again is just the equal sign and the greater than symbol beside each other, stuck to each other. Okay, so that said, let's take a look at like how this works and what the point of all this is, and kind of a bit more of the terminology behind this. So on the left here, I have what's called the function declaration. I am declaring the function. This is very similar to how we declare variables, as we saw in the variables introduction. This only creates the function or initializes the function and points print hello in this case, which is the label or the variable name, at this function construct. Okay, I'm going to show you how this actually looks like in the computer just so it makes a bit more sense later. But for now, you can think of reading this out as we're going to create a function here, an arrow function, right? And we are going to point the variable print hello at that function. We're not going to do anything with the function yet. It's going to have some code in it, and this could be a little bit of code, it could be a lot of code, but it's going to have some arbitrary code in it, and print hello is just going to point at that function. Okay, that's the function declaration phase. So we're defining or declaring the function. To actually use the function though, we need to go into the function call phase, which is what I have here on the right hand side. To call a function, you take the label or the variable name in this case, so the print hello is what we called it, and you just put two brackets, parentheses right after the opening and a closing. And this is called calling the function. Okay, so there's kind of two steps. There's a function declaration, which defines it, and then there's the function call, which actually executes the code inside the function. All right, this code right here, and this could be a little bit of code again or a lot of code, right? So whenever you see this, we're calling the function. That's the way to think about it, and it's going to execute. It's a signal to JavaScript to execute the code inside of the function body. Okay, when we just declare it, we are not executing anything. It's just defining it. Only when we call a function are we executing any actual code. Okay, the nice thing is that once we've declared a function, we can actually call it as many times as we want. So I can call it one time, I can call it 10 times, 100 times, it doesn't matter. It'll execute this code inside here however many times that I actually call it. But to call it, I have to put these parentheses beside the name of the function. All right, so before we get into the code, I just want to show kind of a little bit more on this structure visually, because I found that this really helps. So again, here we have that print hello function. So I'll start with step one. We are declaring this function, print hello, right? Print hello is going to point to a function that does something. In this case, we can see what it does. It console logs hello to the screen, but imagine it can do 100 things. It doesn't actually matter what it does. All we know is it's a function, and we're gonna hopefully call it at some point in the future, since all we're doing right now is declaring it. All right, and that's what happens here. In step two, we're calling print hello, which is the name of this function right here that we declared already. We have to have a function declared before we can call it, just like we have to have a variable declared or initialized before we can actually use it in a program. Same thing here. So we put the parentheses, and that means go and execute the code inside the function's body. So that's what this step 3 here is. It's going to go and find that function and execute the code inside, which is what step 4 is. It's going to start at the first line, and it's going to run every single line from the first curly bracket up here all the way to the last curly bracket. Everything in between it's going to run. All right, there are some exceptions to that, and we can cause it to exit early and things like that, very similar to how a break works in loops. However, in principle, we're going to start at the top and we're going to work our way to the bottom of the function body until we hit the end of the function, the last curly bracket, and then we're done calling that function. And then we can continue on in step 5 here with the rest of the code. All right, so I encourage you to kind of look at this picture and really convince yourself that this is kind of what's happening. It's going to take a little while, but I've found that this visual really helps to kind of trace what is happening, because the difference between the declaration of a function and the calling of a function is where a lot of the confusion comes in, especially when it comes to actually thinking like, okay, when I'm calling the function, what's actually happening behind the scenes? Okay, So given that, let's open up a Visual Studio Code, our favorite editor. I already have a folder open. I'm going to just create a new file here. I'm going to call it functions.js. And in here, we're just going to code this out just to see a couple of examples in practice. So let's kind of go with this say hello example. So I'm going to create a const. I'm going to declare it as a const because it's very rare that you would reassign this to something else. So I'm going to be safe to start, and if that is needed for whatever reason, I can change it to let in the future. So I'll just say hello. And this is going to equal to parentheses, and an arrow function is an equal sign, as I mentioned, and a greater than symbol. My editor kind of puts these together because I have ligatures enabled in VS Code. But if I put these together, you see I kind of get this arrow looking thing right there. And then I put some curly brackets right after, which denotes kind of the start of the function body and the end of the function body. So really the function part of this is like this part right here, right? The parentheses, arrow, and then the open and close curly brackets, right? So we are, in this case, saying create a function. In this case, it does nothing, an empty function. And then we're pointing the variable say hello at it. That's a constant variable. So in here, I'm going to console.log. I'm going to say hello Jello. Why not? Hello, hello, hello Jello. Whatever, whichever we want. It doesn't really matter. We're just going to print something in here. Okay. So this is the function declaration right here. Okay. If I run this file, I saved the file, and my editor likes to move things around when I save it because I have some programs running in the background, so I'll move my comments out. But this is the function declaration. What I want to show you, though, most importantly, is go ahead and open up your terminal, make sure you're in the correct folder, run node, and then the name of the file. And what you'll see is nothing happens. Right? I've made sure I've saved the file, and I'm going to run this again, and still nothing happens. Right? So why is this? Right? Kind of strange. Try to think about what I meant by declaration and calling and see if you can make sense of it. So what's happening here is we have only declared the function. Very similar to this. So like, let's say I create a new number, and I just say that my number is 5. Right? Let me just clear my console, just have some extra space. But if I run this, I don't get like 5 magically printed out to the screen or anything, right? It just exists, and I'm not using it anywhere, right? So I'm declaring and initializing number to be 5. I'm declaring and initialize say hello to be this function. We're not actually using it. Okay, I'm just gonna get rid of this so that we have a bit more space. In order to actually use this function, we have to call it. And to call a function, we just add the parentheses like this, opening and closing, right after the name of the function. Make sure if you're using camel case that you actually match the casing of the function name. You can see I'm using a capital H here. Now what we'll see is if I run this file, we'll get hello Jello, right? Which is great. So this is line 6 is going to execute the code inside the function say hello, which is executing line 3 in this case. So interestingly, if I take this line and I do it a few times, try to think what'll happen. So if I run this, we'll see that I get hello Jello that many times, right? 4 times, because each time it's just doing what we tell it to do. It's saying go call the function, right? This is, you can think of the same thing as literally copying and pasting whatever code we have inside here and putting it back out here. The nice thing is that if we add a whole bunch of extra stuff, right, like say meow, right, and I run this, you can see that now this still continues to work, right? We're calling this function and we're getting this output. This is the first call, this is the second call, this is the third call, and then this is the 4th and final call in my code on line 10. All right, so right here, we are calling the function. Okay, and this is the keyword right here. I spend a lot of time on the kind of nomenclature behind all this or the wording behind all this, because when you're working in groups or when you're explaining your code to others or pair programming in the future, or even in contexts like interviews, for example, there is a huge difference between using the correct terminology when you're trying to explain what's kind of in your head or what's on the screen to someone, in the context of them understanding what you're actually saying. There is just so many things in programming that we have to keep track of, that even small changes in wording can either make the difference between someone really understanding what your intention is behind how you're either trying to help them or code with them or make changes, and someone doing something maybe the opposite of what you are actually asking. Okay, cool. So let's, before we get through more examples, I'd just like to really get through some more visuals, because not only did I spend a lot of time on them, but I really think that they're actually quite helpful. I might be a little bit biased. Please let me know if you think they are helpful. So I created this memory representation of our function. All right, so what's happening here is this. You can think of this as two different sides. We have the code on the left, and then we have the computer memory on the right. Okay, so let's look at the code first. Let's ignore the computer memory for a second. We're seeing that here we have a function called print hello, and it's doing some printing, right? It's printing hello in different languages, and then we're calling the function 2 times. Right, very similar to how we just called our function 4 times. All right, so declaration, calling. So what does this actually mean? What actually happens inside the computer's memory, if you think of the variables video that we looked at, where we're storing these things inside a table, inside the actual computer memory or the computer's RAM, the code, the body for this function, in this case the blue area, pretty much gets copied into that table. Right? It gets a bunch more space, and it all gets copied over there. All right, it doesn't run yet. It just gets copied over there, and then print hello simply points at that code. Right? So you can see that print hello is declared to point at that code block. All right. When we call the function, though, that's where the interesting things start to happen. We then go and follow that pointer in this case, which is print hello, and we go look at where it was declared, and we actually execute all of the code from top to bottom inside of that block in the table in the computer's memory. So we run all of these lines of code until we hit kind of the border or the end of that function, and then we exit. And in this case, we will do it 2 times because we have print hello being called twice. Okay, so think of it in this way. When we're declaring something, we're just storing it to be used later, and we have a copy of it in memory to be used. When we actually call the function, we're executing those lines of code quite literally from top to bottom. Okay, so next I want to go through some more examples, but really getting into this idea of parameters and what are called arguments. This is really where a lot of the functionality and power of functions come from. If you notice our code so far, this is useful, very, very useful, because it actually does some predetermined thing, and we can just worry about calling the function, and this could be 2 lines of code, it could be 200 lines of code, right? There might be a lot of very complex interactions, if statements, loops, maybe even other function calls happening in here. But all of this is kind of hidden from us behind this function call, I should say, right? So the function is called say hello. We just know if we call it, it's going to do this stuff for us. So it's very useful in the context of saving us from having to basically copy and paste this code or try to remember what's in there if it's more complicated, especially if we're using it in multiple files or on multiple lines, just like here, right? This is much better than having to copy and paste it a bunch of times. But there's a lot more power behind how functions work, and that's what I want to show you next. So this is a little bit busy. I want to start focusing on this left-hand side again first before I show you the right-hand side. These are directly related to each other, but let's kind of focus right here to start. So you can see that we have a function. Right, that's the topic of this video, so that makes sense that this is a function right here, right? This function is called print, but curiously, inside of these parentheses, right here, right here, we have a word, right? What is this? Message. What is it? What is that message thing, right? It is just a name. It is just a variable. I have message printed here, and what this allows us to do is treat this as a variable. All right. So imagine that we want to create this function called print, but we want to allow the person calling our function to give us something to print out. Instead of it printing a hard-coded amount of text like hello, jello, and meow here, right? Imagine if we could say something like this. Hey, I want you to print out moo, right? And then here I want you to print out foo, right? This would be probably more versatile because now this function can do more things, right? If I run this code, you'll see that nothing happens, right? Because I haven't actually made use of any arguments or parameters. This is just always going to print out hello, jello, and meow no matter what I give it. I can give it as many things as I want and it's going to totally ignore them. But we can actually not ignore them. We can actually use them. So in this case, this function, if we just look at the declaration, if we ignore the function being called down here for a second, if we just look at this function declaration, the way to read this is that we are creating a function, an arrow function. This arrow function has one parameter. Okay, that's the technical term for how this works. This is a parameter. This can be named anything that we want. This just allows us to use this label or variable inside the function body later. All right. So we have one parameter in our function, and then this is an arrow function that does something, hopefully, with that parameter in its body. And then print is the variable name or the label pointing at this new function. So print is pointing at a function that has one parameter called message that does something with it inside the function. All right. Down here, though, what we're doing is we are calling this print function and we are providing it an argument. And this might seem pedantic, but this becomes very useful as we kind of get more complex and our intuition and explanations for these functions and trying to explain them to each other and move things around, and we kind of combine these concepts. The difference between a parameter and argument is subtle, but it is important. So a parameter is a generic parameter for a function that has not been filled in yet. It is when we declare the function, we define either 0 parameters, 1 parameter, or actually technically as many parameters as we want, which we'll see next. Okay, so that is called a parameter. It has a name, but it hasn't actually been given a value yet. Okay, when we fill in that parameter with a value, when we call the function right here, where we're doing print and then giving it the string OMG does this work, right? Now we're providing an argument to this function to fill in that parameter spot. All right, that's quite a word soup, but rewind and watch that part of the video if it seems confusing. But I'll just say it one more time because it's just so important, right? We are taking this string, OMG does this work, and we are providing it as the first argument to the function print, and it's going to implicitly use that string in place of that parameter. So message is going to change. So I've shown that here on the right. That's the purposes of what we have on the right. When we're calling this function print, we're actually providing a value for that parameter, which is what's called an argument. And then it looks, you could think of behind the scenes, this is really what ends up happening. Message is the parameter name, which is the placeholder, just a placeholder. That's what a parameter is. It hasn't been filled in yet. When it is actually called and given a value, then it transforms into what's called an argument. And now we have this string being passed in here, and then that's the same string that's being used down here. All right. Hopefully that sinks in after a while. If the kind of distinction is still a bit tricky, leave a message in the comments and I'll do my best to kind of elaborate on it more. But don't get too caught up on this. I just want to bring up those two terms because I will be using them personally a lot, and you will see them used in the industry a lot when trying to communicate these concepts. So before we get to the code, I just want to show you that we can actually have multiple parameters. All right. So in this example, we have another function, right here, this function right here. I wish I could highlight like in odd ways. And we're calling it print many, and we're pointing print many at this arrow function. This arrow function is the same as every other function. It's just a function. The only difference is that this function has two parameters. The first parameter we're calling message, and the second parameter we're calling num. We separate parameters in this function with a comma. Okay, then we can actually use these as like placeholders inside the function body. So right here, I'm assuming that num is going to be a number, right? Eventually, we're going to learn how we can kind of do these checks and verify that. Otherwise, we can give the user maybe an error message, for example. But let's assume that we get a number. So we're saying loop that many times until number, and every single time print out this message. So we would use this function like this, and we can use it in different ways. So the first way, we're saying print hello, the message hello, which is what gets put into message as an argument, and then hello gets put here as well. And we're replacing num with 5, right? So this is going to print out hello 5 times if we were to run this line right here. Similarly, right here, print many with moo and 50, right? This would print the string moo 50 times. All right. This allows us quite a bit of flexibility and versatility when creating functions. It's actually quite amazing when you combine these with loops and if statements, with the amount of things you can start doing and the amount of functionality we can make that is actually quite complex behavior. All right, so let's look at an example of that. I'm going to create another file. I'll call this functions2.js. I'll just clear this out and close this for a second. So let's look at multiple parameters. So for example, let's say that we wanted to create a function that takes two numbers and adds them together, right? Like a sum function. We could say const sum equals 2. This is going to be an arrow function. Wrong brackets there. Definitely want to use curly brackets for functions. I usually kind of, my fingers are already in the habit of always, writing out this arrow function syntax. I always like to write it out like this, right? Then I think about, okay, what goes in here? Well, we want to be able to add any two numbers together. Of course, we have the plus operator in JavaScript, which we saw in the math operators video. But let's just assume that we don't, for whatever reason. At least we're going to use this in the actual body. But let's just assume we want to create a function for this, and we can add more complex behavior after. So let's say the first parameter is num1, and the second parameter is num2. All right. In this case, we can console.log, and we can say num1 plus num2, just like that. Okay, so I'm going to take the first number, I'm going to add it to the second number, and I'm going to console log that out. So if I run this, and if I say node functions-2, nothing happens, right? Because all we did was declare the function sum. We didn't call it. If we call this function with, let's just say 5 and 6, right? 5 plus 6 should be 11. Let's see if our code works. And indeed we get 11, right? If I call it with 10 and 10, and I run this one more time, I'll get 20, right? So it works as expected, which is fantastic. What's really kind of interesting is if we don't provide it anything, okay? We get this weird nan. All right, and what happens if we maybe provide it, only one value, and I try to run this? We also get nan, right? So what on earth is happening here? What happens if you don't provide a value for a parameter in JavaScript is by default, it is assigned undefined. Okay, so what's happening in the case of line 7 here, where we're calling sum with no arguments, we're not giving it any arguments to fill in for the parameters num1 and num2, it's actually going to assign undefined to num1 and num2. So let me just show you how that works. I'm going to comment out all these other ones. And before I actually log out the sum of these, I'm going to log out num1 and I'm going to log out num2, just so we can see what those values are before they get added to each other. And if I run this, you'll see that I get undefined for num1 and undefined for num2, and then we add undefined plus undefined and we get nan, right? In the primitive types video, we saw that this is actually one of the primitive types, and it's a really funky one. It's not that often that you might come into contact with nan, but it's short for not a number. It's just kind of like JavaScript version of cannot compute, right? It's just like, what does this mean? I don't really understand what this is. So be careful when you're calling functions to actually keep in mind how many parameters that function has and if they're all required, or maybe some are optional. In future videos, we'll see how we can do advanced things like put optional optional parameters which have like default values, for example, and all these types of more complex behavior to add onto this. But to keep this video short and sweet, I just wanted to show you that by default, if you don't provide an argument and it's expecting an argument, it's going to be undefined. So just be careful with that. However, as we saw, we can use it correctly like this. There are ways around this where we can do checks, as I mentioned before, and we can warn the user that this is not the way the function is supposed to be used so that we don't accidentally do weird things like this, but that is for a future video as well. Okay, now, this next thing I want to show to kind of wrap up the basic concepts for functions is probably the hardest to wrap your mind around the first few times. So I'm going to go a little bit slower with this one as I explain it. There is a special keyword that is only usable inside of functions. This is the same for most programming languages. And this is the keyword return, right here, return. This allows us to not only take inputs to a function, which is what parameters and arguments allow us to work with, where we can give something to a function to do some computation with, but return allows us to have some output to the function as well. We can actually get a value out of the function and use it somewhere else. So what does that mean? Let's look at this code right here. We have a function right here, an arrow function, that has two parameters, num1 and num2, right? Same as what we just wrote. And it's called sum, also same as what we wrote. And the difference here is that we're not doing a console log inside the body. So let's look at what happens. If we run this code here, it's going to call the function with arguments 10 and 20 for num1 and num2 respectively. What we can do is we can take advantage of the fact that now instead of just console log, this sum function has a return statement inside of it. So if we were to actually try to assign the result of calling this function to a variable, this would actually give us a value. So for example, if we ran this line of code right here, const result is equal to sum 10 and 20. I'm going to read this out as explicitly as I can. What this line right here is doing is saying call the function called sum with the arguments 10 and 20. We know that when we do that, we're going to come up here and we're going to fill in num1 with 10 and num2 with 20. Then we're going to enter the body of the function. And we're going to replace num1 with 10 and num2 with 20. So we're going to do return 10 plus 20. 10 plus 20 is 30. So this is going to change to return the number 30. What does that mean to return the number 30? Well, what happens is we look to see if this value that we're evaluating inside calling this function is being requested anywhere or being used anywhere. In this case, we have an equal sign, which means that we want to take that result, that value that we get from evaluating calling sum with 10 and 20, and we want to point result at it. So we're going to take that 30 and we're going to basically put it in result, or point result at 30. So we can actually get that value out of the function to be used outside of these curly brackets. Okay, that's the only real way, or the correct way, I should say, to actually get values out of a function into the rest of this world out here, outside the curly brackets. And then if we were to console log this result, we would actually see the number 30. Okay, you might be curious what happens if we don't have return in here, which we'll get to next, but I do want to show you this in practice in code really quick. So if I create another file, let's call this functions-3.js. Close this just to give myself some space. So let's just say we have a function called sub. So we'll say, or actually let's do multiply, for just to make it different. I was going to do subtraction, but we'll do multiply. And this is going to be an arrow function. And this is going to take a num1 and a num2. And a function doesn't need parameters to return something. You can return anything it wants. But let's just be fancy here and do a couple things at once. I'm going to return num1 multiplied by num2. Okay, so I'm just going to multiply these things together. But most importantly, I'm going to use this return keyword, which is a special word in JavaScript and most languages that means give this value back to whoever called me. All right. So again, just to really nail this in, if I run this with functions3, I'm not going to get anything because all I did was declare the mul function. Okay. If I call the mul function with, let's just say 2 and 3, 2 times 3, oops, 2 comma 3, I tried to do the multiply right away in there. That's cheating. If I wanted to do 2 and 3, so as arguments, 2 would go in num1, 3 would go in num2. I would do 2 multiplied by 3, which is 6, and then I would return 6. So this would evaluate to 6. This would be 6, right? Let's see if it gets printed out. If I run this, I still don't get anything printed out. Okay? And that's because we're not telling it to do anything with that value. It's just giving us 6, and then we kind of end the program. We're not doing anything with it. So there are a few ways that we can see this. I can create a like const, like result. It can be called anything. I'm just going to call it result is equal to calling mul. Let's just say 10 by 10. If I multiply 10 and 10, I should get 100. And then if I console log out result, now I should get the actual value, which is 100. Okay. So what's happening here again, just to be extra clear, we're calling the mul function with 10 and 10 as arguments for num1 and num2 respectively. 10 goes here, 10 goes here. So this is actually 10 times 10 in the case of this line right here. And we're returning 100. Okay, so this is effectively return 100 is what happens. This 100 gets put here. So this is actually what ends up happening. We say const result is equal to 100. This is what ends up being evaluated. Okay, because this evaluates to 100. And this is actually what happens behind the scenes. And then when we print out result, of course, if we see this like this way, it's obvious it'll be 100, but that's also what's happening over here. Okie dokie. So the confusing thing, and this is a question that might be niggling at the back of your mind, is, well, what happens if we don't return anything? What kind of gets returned? Does anything get returned? Right? And that's what I'm demonstrating here, right? So same example. Let's say we have a function, let's call it move to be fun. Num1, num2, same things before. We're console logging out num1 and num2, but we're not returning anything. If we call this, we're going to actually get 30 printed to the screen, just like our very first example. If we, however, assign to result or point result at whatever sum 10 and 20 evaluates to, whatever it returns, what are we going to get, right? Because it doesn't seem to be returning anything. Okay, so let's take a look at this. I'm going to create one last file. I'm going to call this functions-4.js. I'm going to create a constant called hello, and this is just going to have no parameters, and I'm going to just say console log kind of yo. Yo. All right, there we go. If I run hello, I should get yo printed out, right? Oops, ran the wrong file. I should get yo printed out, right? Which I do, which is fantastic. But what is this returning, right? So if I say const result equals to calling hello, and then I console log out this result, ooh, not resize by, definitely not that. If I console log out result, what is this gonna be? I want you to try to think about it, take a guess, and then let's take a look together. So, moment of truth, if I run this, it looks like I get yo, which gets printed out, but then I get undefined, and that's what's happening on line 8, right? That's this line here is what's printing out undefined. This yo is happening here when we first call the function, which is what's happening here. But the result of calling this function and then printing it out is undefined. So the return value for every single function in JavaScript, whether it's a regular function or an arrow function, is undefined by default if you do not override it and provide your own return value. Okay, so by default, no matter what, built into JavaScript, every single time your functions are going to return undefined. So you can think of this as basically doing this behind the scenes. And if I ran this, you would see it would have the same behavior, because that's actually what ends up happening behind the scenes. If we want to override this, right, we don't actually have to type it out because it happens by default. But if we want to override it and provide our own value, for example, let's just return hello. And I'm returning a string hello in this case, which this is actually going to eventually be this const result is equal to hello the string, right? Now I've overridden undefined and replaced it with this new overridden value. So you can see that I get hello now being printed out, which is happening on line 10. Okay. Very, very important point. There are many bugs that happen as a result of thinking a function returns something and it doesn't, or not realizing that you're using the return value of a function to do some kind of computation or logic, and then it being undefined. And as we saw in the kind of examples over here, where if you give something undefined and you try to do things like math with it, you will get things like nan, not a number. Sometimes you get other weird behaviors. Sometimes you might even just have your program kind of stop running or give you an error or kind of blow up, right? And that's not what we want. We want to make sure we know what's happening. So if a function doesn't return anything by default, it's undefined, we can override it by returning anything that we want. In this case, I'm returning a string. Okay, so I've created a set of problem sets and exercises for this function video to go through even more practice together. So if you feel like you'd like to go through those, I'll see you in that video. If you found this video valuable, please like the video and subscribe to the channel. As well, I'd love to hear what you think of the video in general, the drawings, did they help, were they helpful or unhelpful, as well as any other examples or questions you might have in the comments below. In the next video, we're going to go through those problem sets as I mentioned, and following that, we're going to go into another one of my favorite topics, which is arrays in JavaScript, which allows us to finally start working with collections of data, and we can kind of group them into these lists. Super excited for those ones. I'll see you in the next videos.